This video is going to introduce a concept called the mole, which is a number that helps us bridge the gap between the microscopic world of atoms and the real world where we can actually measure things on a scale. Let's begin with an example that shows why we need this concept of the mole. If you consider an aluminum can has a relatively small mass. An empty can would be about 14 grams. 14 grams of aluminum is roughly this many atoms of aluminum. It is a huge number of atoms because atoms are so tiny. A chemist is not going to report something in terms of numbers of atoms because it's too easy to make a mistake when you have to deal with that many zeros. Instead, a chemist would divide this number by another giant number and report moles of atoms instead of atoms. So what is the mole? The mole is just a number. So when I say the word dozen, you think 12. When I say the word mole, you should think 6.022 times 10 to the 23rd. It is called Avogadro's number, and it is used by chemists as a bridge between the microscopic world and the laboratory world. In the example I just gave, we could take this many atoms of aluminum and divide it by the number for the mole, and then we would say instead of this many atoms, we have 0.52 moles of aluminum. It's a much friendlier number to deal with. So by counting in units of moles, it allows us to deal with much more reasonable numbers. So Avogadro's number is a conversion factor that can help you convert between something that is very small, like an atom, to a number that's more reasonable to deal with. You're not limited to using it for atoms. You could use Avogadro's number to count anything that was really tiny. You could count atoms, you could count particles, you could count molecules. So you are not limited to just using Avogadro's number for atoms, just like you are not limited to using dozen to count eggs. You could count 4 dozen people, and it still means 4 times 12 number of people. Here's an example where we are going to use Avogadro's number as a conversion factor. It says how many moles are in 1.2 times 10 to the 21 atoms. So that's a huge number of atoms. When you set a problem like this up, you should always start with the number and the unit that you're given in the question. 1.2 times 10 to the 21 atoms. And then set up a fraction, so times some fraction. Next, focus on the units. You want the unit that you started with to go on the bottom of your fraction. That way it'll cancel out. So on the bottom of my fraction, I have atoms, and I'm going from atoms to moles. There are 6.022 times 10 to the 23rd atoms per 1 mole. This is a conversion factor that could be flipped if I needed it to be, but because I'm starting with atoms, I need atoms to be on the bottom. At this point, you would multiply by anything that's on the top and divide by anything that's on the bottom to get your final answer, 0.0020 moles. If you're trying this example in your calculator and you got a different number than me, I want to take a minute and look at how you should put this in your calculator and show you some common mistakes that students make. It is very common when you're dividing by an exponent to end up putting it into your calculator wrong, and you'll end up with the right numbers in your answer, but the decimal is in the way wrong position. So I want to show you some ways that you can avoid that. One possible way to do that is to make sure that you put Avogadro's number in parentheses. You could put 1.2 times 10 to the 21 divided by, open your parentheses, 6.022 times 10 to the 23rd, and then close your parentheses and hit enter. If you don't do that, your calculator is going to divide by this part of the number and then multiply by this part of the number, and your answer is going to be off by a factor of 23. Your decimal is going to be 23 places in the wrong direction. Another way that you can do that, which is my personal favorite, is to use this EE function that's on your calculator. Many calculators have it underneath the comma. The EE function does the times 10 to the portion for you. So to put this into my calculator using the EE function, I would press 1.2 and then I would hit second EE 21. That has entered this number for me. Then I'm going to divide by 6.022. I'm going to use the EE, second EE 23, and hit enter. If you put it in that way, your calculator will not make the error of dividing by this and then multiplying by that. Your calculator will do the math correctly if you use that EE function. But just to recap, you want to start with the number you're given in the problem. Whatever unit you have here needs to go here. Avogadro's number is a conversion factor that can go between something tiny and a mole. Let's look at another example. This time we're going to start with moles and convert to atoms. Notice that the pattern that we're going to follow to answer the question is the same. Always start with the number and the unit that you're given in the question. So this says how many atoms are in 3.9 moles. I'm going to start with 3.9 moles. I'm going to set up a fraction, and then I'm going to think about my units. The unit that you start with goes on the bottom of the next fraction. So if you're comparing this to the example we just did, notice that this fraction is flipped now, and the reason for that is that I need moles to cancel out. Avogadro's number tells me that there are 6.022 times 10 to the 23rd atoms per mole. Then I'm going to multiply by that number this time, and I will get a final answer of 8.6 times 10 to the 21 atoms. Notice that my unit for my answer is in atoms because moles has canceled out. And you can use this concept of the mole to convert from anything that's tiny. Particles, molecules, formula units, anything that's tiny to 1 mole. Stick around as we look at another conversion factor that uses the mole that helps us convert between moles and grams.